All right, how's it going, class? Welcome to your second to last lecture. This is the second lecture in our final unit on applied microeconomics, or the branch of economics that studies the analysis of data. This lecture will be talking about distributions and histograms. We'll be talking about how common distributions arise, and we will be looking briefly at how our survey data are distributed. Okay, so I want to start off by giving you guys sort of two seemingly unrelated examples. The first example is an age-old political question, okay, having to do with what determines people's incomes. Okay, why is it that some individuals in society are rich, whereas others are poor? Now, people from different sides of the political spectrum will tend to give you different answers to this question. Okay, liberals will tend to emphasize, for example, social factors that are beyond an individual's control. How rich your parents were, your gender, your ethnicity, where you were born. Okay, and they'll say that well, these factors go a lot towards determining your income. Whereas conservatives will, of course, tend to more so emphasize the role of personal responsibility, a person's worth ethic, perhaps, their maturity, their attitude, in explaining why some individuals, for example, might have more success in their careers or might be better off as compared to others. Okay. Now, obviously, there's an element of truth in both of these views. Okay, on the side of the conservatives, I think we have to admit that it's hard to succeed in anything if you aren't willing to work at it. And if we look back on our own lives, usually we can identify how our own choices have influenced our present state. That having been said, I think the more we learn about the world and about society, the more we sort of zoom out and look at some of these broader patterns, the more we see the impact of random factors that are beyond any individual's control. In this lecture, I'll show you some evidence that the distribution of wealth in any country is governed by these types of random forces. Okay, so that's coming up. Okay, so that's just, it's just, think about that. Keep that example in the back of your head. Okay, now let me move on to the second example. Okay, so this example involves flipping a bunch of coins and determining which is the real randomness and which is the fake randomness. Okay, so let me show you some data. Okay, so here I have some data. What this is it's 100 flips of a coin. Okay, and in fact, I have two such data sets. Look at this. This is trial A. Have a look at this. This is trial B. Okay, and this is simply, this is 100 flips of a coin. Okay, now, one of these data sets was generated by actually flipping a coin 100 times. Okay, I had my students laboriously flip a bunch of coins 100 times. Okay. The other one is I had another group of students basically just make up the data. So they didn't actually flip a real coin. I just told them, just make it look like you did. Write down a bunch of heads and tails and just make it look like it's random. Okay, hopefully that makes sense. Okay, so one of these is real data from 100 coin flips. One of these, a bunch of students, they just made it up. Okay. So now here's my question. Have a look at these two. Okay, and of course you have the link to this as well. Which one do you think is the real randomness? And which one do you think is the data set that's just made up? Have a look at those and think about which one you think it is. Okay. So you might be thinking, okay, well, how are those examples related? And how are those things related to the topic of this lecture? Well, you see, both of those questions all involve being able to distinguish a non-random pattern from a pattern that is truly random. Both of those examples involve being able to distinguish a non-random pattern from a pattern of results that arises only from chance. How can we distinguish between chance and something else going on? Okay, and this question here is going to form the basis of our lecture today. You see, before you learn applied microeconomics, before you learn to study data, usually a prerequisite to doing that is to understand something about probability. Probability is the basis of the branch of mathematics known as statistics. And of course, statistics is the branch of mathematics relevant to the study of data. Okay. Now, this is reflected in, for example, the way the courses are scheduled in CNU. Okay. So, for example, to take econometrics, which is basically just an applied micro class, you first need to take Math 215, which is a course in probability and statistics. Okay. Now, um, okay, so let's think about that a little bit. Okay, so statistics is, of course, the branch of mathematics dealing with the collection, analysis, interpretation, presentation, and organization of data. I ripped that definition straight off of Wikipedia. Okay. Now, I think it's pretty obvious why you would need that if you were going to analyze economic data. Like, it's clear why statistics is relevant. Okay. But what about probability? So, because you take these classes and it's usually the same class, right? Probability and statistics. Probability theory is the branch of mathematics concerned with probability or the analysis of random phenomena. Okay. So, but once again, we have this question like, well, why do you need that, right? It makes sense why you need statistics, but why would you need probability theory in order to go analyze some data? Well, because, you see, it's because of this question that I just asked. How do you distinguish a non-random pattern from something that results only from chance? Whenever we look at any piece of data, we find patterns. Okay, you look at any piece of data, you're going to find some patterns. And one of the fundamental tasks of an econometrician or of an applied microeconomist is to determine which of those patterns really represent some kind of deeper process within society, and which of those patterns aren't patterns at all. Which of those patterns are simply the result of random chance. Okay. Is it a real pattern or is it coincidence? To put it another way, how confident are we that a given statistical result is what's known as statistically significant? Now, answering that type of question, okay, is a field of statistics known as statistical inference. And this is basically, it's a fundamental topic within statistics. Okay, so the answer to these questions, okay, is this. In order to understand whether something is truly random, in order to understand whether something is the result of chance, we simply need to know what chance actually looks like. What does it look like, right? And the thing is, the interesting thing about chance is that it does exhibit a pattern. I know that seems counterintuitive, but chance itself, randomness, has a pattern to it. Okay, so in the next segment, okay, we're going to delve deeper into this question. Hopefully, I've sort of motivated the lecture a little bit. Okay, we're gonna in the next segment delve deeper into the question of what does chance actually look like.